All right. So here's a boring Pentomino tiling that I came up with. So what can we do to make this a little bit more interesting? Oh, there, it has color. So that's more festive. So just as the colors make it more visually interesting, the problem of finding interesting colorings on top of Pentomino tilings is sort of an extra layer to make it more intellectually interesting with this, to deal with this sort of problem. So let's go with sort of more normal Pentomino tiling. So we have the four color theorem, which says that we can always find a map coloring that has four colors, which is nice, but we want to have interesting colorings, and if you can always do that to any tiling, then, well, what can't we do sometimes with some of the tilings? We want to find something that's more interesting than that. So one way that we can add a restriction to the coloring is to say, what happens when we have a crossroads like this, where we have pieces that come together at four pieces that come together at a corner. Normally, we say that doesn't count as touching, because that's what makes the four-color theorem and a lot of respectable mathematics work. I am not a respectable mathematician, so we can make that count as touching if we want to. So those two green pentominos that are at that plus sign there, if we're looking for a strict coloring, which is what I'll call it when that counts as touching, that would not be a strict coloring. But we can fix it by swapping the colors. So now the question is, can we always fix it in this way? And, well, yes, we can. So that makes it not a way of making an more interesting way of finding Pentomino colorings. Well, we can unless we're doing something silly like having a vertex that has 5 squares coming into it. Or if we mix in the tetrominoes here, we have all these 5 pieces that all touch each other. Unfortunately, the pentominoes by themselves aren't quite nimble enough to wrap around each other in this way. You can also go up to the hexominoes and find some solutions that way that are not strictly four-colorable. So that wasn't a good way of finding more interesting, nice colorings. Another thing we can do is go down to 3 coloring. So we have the 4 coloring of this particular tiling. And we can also go to a 3 coloring of that particular tiling. This is the slide where I apologize to everyone who is colorblind. I'm going to go back to more colorful colors after this. But anyway, so this is 3 coloring. Notice that it is also a strict coloring. There's no corner that has 2 of the same color meeting at the corner. And it's actually, the 3 coloring implies that there can't be any crossroads, because so the strict 3 coloring implies that there can't be any crossroads, because if you have 2 that are the same color that meet that way, there's 4 corners and 3 colors, and that's not enough for that to work. But this particular tiling is particularly nice, has a particularly nice coloring. And if you like to anthropomorphize your Pentomino tilings, which I recommend, this is what I call the happiest tiling, because it's the unique tiling where you can do this. Overlaying the 3 coloring with the 4 coloring, both strict, such that all 12 combinations of colors are present. So that was a problem that I came up with in, I'd say, about 2001, and Günter Stertenbrink found that solution. Now, the other nice thing about this tiling, aspect that I haven't gotten to yet, is both the 3 coloring and the 4 coloring are balanced. This is where it comes in handy that 12 is one of these annoying numbers that has lots of factors. there's 3 each of the 4 colors in the 4 coloring and 4 each of the colors in the 3 coloring. So we have these aspects that we think are nice about tilings. There's the strictness, balance, and having a 3 coloring rather than just a 4. So let's look at statistics of how many have all of these things. So you notice that with the 4 colorings, adding the extra restrictions doesn't really cut down very much on the number of tilings that we have. With the 3 colorings, then that just having 3 colorings at all cuts it in half, and then adding more restrictions cuts it down way further. So this is a good way to find really nice tilings, is to go for the 3 colorings that are strict and balanced. But one other thing about that, you notice that there's just 2,338 balanced, non-strict tilings that are 4 colorable, that 6 by 10 rectangle, which means that we're missing one, which would make that the saddest tiling. And so to see why it can't be balanced, notice that F pentomino on the right touches all the ones that are on the right of that thick line, so none of those can be that same color, and of the other 3, only one can have that color, and so you can't get to the 3 of the same color that you need to have a balanced 4 coloring there. And I'm done, thank you. So normally you can't do 2 colorings, but here's a 2-colored packing, and I'll leave you with that.